Welcome, everybody, to the webinar Securing Your Software Supply Chain with Spinnaker. My name is Mark Levy. I will be hosting today's webinar. I focus on product marketing here at OpsMX. Before we start, a few housekeeping items. Session today is going to be about 45 minutes long. We're recording the session. We'll send the recording, the slides to everybody. If you have any questions, please put them in the chat. And we'll answer questions after Gopi's presentation or in the LinkedIn Live. If you're joining us from LinkedIn, welcome, and put them right into the conversation, into the comments section. So for those of you, just a quick overview for those of you that are not yet familiar with OpsMX. OpsMX delivers software and services intelligently, securely, and automates software delivery, leveraging on an open DevOps architecture and deep CI/CD experience to empower enterprises to ship better software faster. Check us out at opsmx.com. So what I'd like to do today is introduce our speaker today, Gopi Ribala, who is our CTO here at OpsMX, where he has overall responsibility for machine learning and the architecture of OpsMX solutions. Gopi also has very strong connection with the Spinnaker community, leading design and architecture for strategic implementations. He's a frequent speaker and a well-known leader in continuous delivery overall. Gopi, good morning. How are you?
Good morning, Mark. I'm doing well. Thank you.
Great.
Should we just start the presentation?
Let's dive into it. Yes.
Okay. Well, thank you, Mark. Greetings, everyone. And thanks for the generous introduction, Mark. So today's agenda is simply using Spinnaker for securing your software supply chain. So now we want to just touch on the motivations, why now software supply chain security, and what are the challenges and how the regulatory environment changes are affecting the requirements within the enterprises. And so we will touch on what the Spinnaker capabilities are and how you can use the built-in capabilities of Spinnaker in achieving your securing your software supply chain. And also some of the additional things that you may need on top, you will need on top for the Spinnaker for this enterprise-wide supply chain security, including some things for governance and audit capabilities. And then we'll do a quick demo of some of the features that we talk about in the presentation here. All right, just jumping into it. So why now securing software supply chain? Just to give a brief intro to what is secure software supply chain, right? Similar to regular supply chains of the goods that are going around, the software supply chain not only includes the composition of the software that is deployed in your production environments, but also how it is built. That includes how you're managing your version control system, how you are doing the build, what are the build software that you're using, which versions, and what is the delivery process. All of it is included. The main reason the focus here is that there is an increased attack surface that was identified with the supply chains in the last 2-3 years. And because of the increased surface area that's available for attackers on the supply chain, that became a primary target. So there is an increased security risks, and there is a lot more attacks that are happening on the supply chain in the last couple of years. And we're also using a lot more of the open source software in the enterprise software that we are delivering. And so Synopsys did a survey and found that almost 80% or more than 80% of the software that are being delivered use the open source software that are 2 years or older, which means that there are high chances of vulnerabilities identified in this open source that are not yet resolved. So the kind of issues bring urgency to addressing the security issues in the software supply chain. So one of the issues that we commonly see is that the businesses have a focus on delivering new features, getting new customers. And because of that, we see this DevOps process adoption and a continuous delivery processes adoption. With that, the security is added on, right? And so because of that, there is a lack of securing the process from the beginning. So which is, again, a driver increasing the surface area, causing a lot of vulnerabilities in the supply chain itself. And then in an enterprise, because of too many types of tools that are used by different groups, ensuring that the security of all the tools involved in the supply chain of the software delivery becomes a challenge. So that brings in this urgency in terms of adopting new tools, new processes in securing your software supply chain. So what we'll do is we'll go through some of the issues with changing the regulatory environments that are also causing this urgency now. And so as you know, this Executive Order 14028 by Biden administration put a focus on the supply chain security, and NIST working with NSA and CISF come up with these guidelines that improved on the NIST 800 for the software delivery processes, particularly with the 53 and 2 and 8 standards coming up with SBOM improvements, and how the federal government requiring this secure bill of materials for the softwares that are being used by the federal governments are also causing changes in the enterprises and how they build, deliver software. So this is another driver that's causing change in processes or tools requirements in the enterprises. If you look at the software delivery process itself, so what do we mean by increase the surface area, and where are the problems that are coming from? In the last couple of years, the attacks that we have seen start from the source code itself. We'll touch on a few of those soon after. There are the attacks that happen in the source code, like checking in malicious code in well-known public open source libraries, or hijacking the build systems. So it introduces the code during the build. If the code doesn't exist in the source control, but it gets injected during the build, and when you're deployed, it runs the malicious code and causes exfiltration. You could also have the artifacts in your repository that get deployed that are not verified. So there are a number of places these issues are occurring in the supply chain, and the new tools and new processes should be able to address the vulnerabilities that exist at different stages of the build and deploy process. Here are some of the examples that of the supply chain attacks that we've seen in the recent past. So NPM math.js. Math.js is a library that is commonly used. So this malicious user created another library called math.js min and published it. So anyone who uses math.js min, assuming that it's the same as math.js, would get the same features, but it has a malicious code built in that would connect back to a remote system and compromise your credentials or local system. This one of the common things that we have seen also is promoting an incorrect image into production. So essentially the image that is tested, that exists, is not the latest one in the repository. But when you deploy to production, if you don't have the proper checks, you may promote the latest one into production that may have some issues. And it's one of the common issues. In 2021, one of the hedge funds lost millions, hundreds of millions, because they promoted an incorrect one or did not deploy the correct image there properly. Similarly, Homebrew is another one with, in the Git repository, there was a bug in the PR merge process, auto merge process. And so any malicious user can submit a code with the PR with a specific structure that gets merged into the main branch and now gets distributed to thousands of developers that are using on their system. And the interesting one, I probably won't go through all of them. You all know about the SolarWinds and the extent of the damage that they were able to do. Circle CI is one of the recent ones where the administrator laptop was compromised. And with that, they were able to compromise Git repositories of hundreds of their clients. So simply by looking at these supply chain issues, one was able to compromise a fairly large footprint. And so that brings in an urgency to addressing these supply chain issues. Now, what are the challenges in addressing these supply chain issues? So one is that in the enterprise, they have the fragmented tools, and there's different development groups are using different set of tools, and having a common set of policies to support the build and delivery becomes harder. And because of this large number of services that are being built using the open source systems, it's not easy or practical for a small security team to be able to verify the efficacy of the build and delivery processes. And usually the manual approvals and the policy enforcement at scale doesn't work. Typically what happens is there are exceptions taken in the last minute, and there is no good way to track these exceptions. And at some point when we do a compliance audit, you would find that there are these non-compliant systems that are running for months. And being able to trace the vulnerability is another issue. So when Log4j issue was discovered, some of the organizations took months to figure out what are all the systems that they are currently running that are affected by it, not resolution, but simply affected by the vulnerability. So we need better systems to be able to trace where the vulnerable systems are running and being able to respond to those. And the manual audits are definitely a lot harder at the enterprise scale. So again, some tools are needed there. So now, addressing some of these issues, we'll see how we are working with Spinnaker in our delivery systems with our customers and addressing these. Right? We are assuming that you all are mostly familiar with Spinnaker and understand the core features, but quickly to touch on it, Spinnaker is an open source tool introduced by Netflix and supported by Google and used by a large number of enterprises today. It's an open source. It has thousands of users in the Slack channel. It's very good at doing multi-cloud deployments. It has deployment strategies that are built in, like progressive deploy, blue-green, to various cloud environments, including, say, Kubernetes, AWS, GCP. It supports cloud-native extensions to increase the capabilities of the core Spinnaker. The pipeline constructs is very powerful. It's visually creatable. It has template structures that allow you to create the workflows and collaboration capabilities. So you have the views for the SRE, and if you have the views for the DevOps, you can have the permissions separated those between the SRE and DevOps, and it has a not proven scale and extensibility as a large number of organizations. Now, what are the security capabilities of Spinnaker that are already built in? So Spinnaker has a pretty strong RBAC built in for the applications or workflows and the target environments. It has integration support for the SSO, so it has MFA support built in. It has X509 for the automation, API automation. Some of the built-in structures, also the process security. We need to be able to say one has to follow certain process to go to production and audit the change in processes. So you can lock the process itself from the UI, so you cannot change it. And the only change that can happen is from the backend, so possibly with a Git. You can also control the read-only structure for the clusters that are displayed in the UI. It also supports built-in with the secrets integration. So you have this encryption at rest and encryption in transit capabilities that you can deploy with the Spinnaker. It has built-in audit event generation, strong monitoring support. So you get all the significant capabilities with the Spinnaker from the built-in system. But if you look at the development security and delivery, there are this process security as well as individual point security checks one has to do, which needs extensions to the Spinnaker of open source itself. So if you look at how these checks need to be done at different stages, you'd see that at the source control itself, you need a certain number of compliance checks. At the build, you need a certain number of compliance checks that needs to happen. And in the process, you have additional compliance checks that needs to happen. And the binary image that got built for the provenance, we need to be able to build the bill of materials for this image itself, image at the time of the build. So, and have the provenance check that is done for those images. So now, this is the kind of how we think about improving the Spinnaker functionality to get to the securing your supply chain. One is the improving the infrastructure security by addressing the vulnerabilities built in for the Spinnaker services as well as the plugins that go with the Spinnaker. The second one is this operational security, where you provide better processes for securing the pipelines. And so here, the policies that are required to go to production needs to be specified organizational wide and should not burden the developers to understand all these specific policies and how to implement them, but provide the guidance on how those are implemented and give a templated pipeline structures to the developers who can simply use the templated structures to deploy. So the process, there are fundamental constructs in Spinnaker that are already there, but we need to provide the processes and constructs on top that allow them to do that. And so that includes the secure onboarding of new services or applications and developers to the system. And then we need to be able to provide the integration with the security tools. For example, if you're using SonarQube for static code analysis or Aqua for the binary scans, for the container scans, we should have the capabilities built into the Spinnaker that allow them to simply use the check as part of the pipeline and not have to do a special integration. So these are the extensions one would need available to the organization to quickly implement those. So to that effect, if you see the workflow itself, the kind of checks that needs to happen at different stages of the workflow, typically these are the kind of checks that we support with the Spinnaker pipelines. So at the dev process, you have the Git branch checking policies, vulnerability checks, and the licensing checks that also can also go in as part of the pipeline. And at the binary creation, you have the binary scans, and after the deploy to testing, you have a DAST analysis. We also allow support for the process checks for the enterprise. Enterprise may have a specific way of ensuring the process checks, approval process with the Jira or a ServiceNow. So the integrations to these Jira or ServiceNow are built-in plugins that go with the Spinnaker distribution that allow to be part of the Spinnaker pipeline. And at the deployment time, we have the ability to do progressive rollout. That's part of the checks that happen at the deployment time to ensure incorrect image, not just in terms of the tested image, but also in production, verify that it does not create any new issues during the rollout process. And then there is a threat model that for that application supporting the ingress egress checks, and you can convert that into the policy that can be checked at the deployment time, along with the provenance of the build systems. So what does that look like? So this is a platform, intelligent software delivery platform that is built on top of the Spinnaker functionality that supports some of these extensions that we just talked about. And the extensions being securing the delivery with the governance rules, extending the Spinnaker with the plugins that needed for the integrations, provide centralized audit and traceability for all the pipelines executions that happen that deploy to production. We have a centralized way of auditing exactly what the workflow was and what kind of checks were done, and provide provenance information for those pipelines. And so we'll quickly look at what those mean. So what are the secure delivery capabilities? So with introduction of these security checks as part of the pipeline, and the policies that verify that the results of the security checks are there, you are going to get secure DevOps control plane, which allows us to provide central rules for the SecOps team that can drive the approval process for the delivery from the security perspective, and provides a complete audit of the information that was generated. And the automated risk assessment includes the checks that were done both on the security, but also include the progressive delivery checks at the deployment time. And with these policy checks, you have the ability to support manual approval. So what that means is that after the security checks are done, it could be sent to something like a ServiceNow for a manual approval, or you can have policies attached to those data that does automated approval for those. So we looked at some of the attacks that could happen, that happened in the last couple of years, and how those can be addressed with the system that's being proposed here, or we are currently using here. If you take an example of promoting incorrect image to production, here we're looking at the build time, SBOM generation, and then in the QA attesting the particular build that has been tested. So at a time when you're promoting to the production, the annotations on these build images can be checked to see if that is the build that was tested and approved by the QA before promoting to the production. If those signatures are not there, that image will not be promoted to the production, and you can stop promoting the images that are not fully approved at the integration environment or the QA stage. Similarly, Math.js. So here, when a Docker image is being built with the open source packages, so because we are able to do a continuous build and delivery, we have this notion of comparing the changes between the previous build and the current build. With that, we can easily see what are the images or third-party libraries that changed. And then with those changes, if we see the signatures are not matching, we could alert, and then that becomes a manual judgment at that point to identify whether that can be promoted to production or not. Right. All right, so now that we looked at the process in which we can promote the secure systems, let me also show you a quick demo on how we are currently implementing it with the Spinnaker and using the Internet ISD platform to manage these policies. I hope you're able to see the screen here. This is the ISD platform that we introduced on top of Spinnaker. You can actually go to the Spinnaker directly from here to look at the Spinnaker pipelines. Let me give a quick overview on what this looks like. Here, you see all the applications that are defined in Spinnaker with their RBAC, and it's a single sign-on. When I log in, I will only see other applications that I have access to, and can go into the details of each of those applications. So here we are defining these policies. We have a pre-built set of policies that allow you to specify integrations to third-party tools and what kind of rules that you would like to apply in your delivery process. So these are prepackaged policies that come with the platform, and the integrations to different tools also comes with the platform. So you simply have to configure saying these are the third-party applications or security tools that we are using. And then you see the active status of these policies. You can we can make these policies active or inactive depending on an application. And at that point, any of these pipelines that run in Spinnaker will take the active policies and apply to those. Right? For example, in Spinnaker, you can create an applications without a RBAC, but you can specify policies saying that applications must have an RBAC to be created. And you can enable this policy. From that point on, Spinnaker would not allow creating any of the applications without RBAC in them. And for the, here is an example of an application with a pipeline that has security checks built in. So when we try to build an application in, that has the Sonar Cube SAST checks that fail, it automatically rejects that one. You can look at the details for those rejection status, and okay, this one was overridden by the new image that were passed, this one. So you can see the integrated approach and the policy that we specified in the policy, specifying what kind of results are allowed to pass with the Sonar Cube, automatically allows it to pass it. And then if you look at the rest of the pipeline, you also see that there is an approval here that essentially checks the entire process for the build ID. You can have changed these policy rules specifying for deploying to production. We need to have the rule 1, 2, 3, 4, 5 need to be approved, and it essentially goes through the entire check and identifies what the policy checks were and if they are successful to be deployed. And once they are deployed, you can see different environments in which the services are running for that application. And for a given environment, you can also see as a compliance audit the kind of checks that were done and the approvals that were given, who gave the approval and what kind of checks were approved as part of the deployment process for this specific application. And you have all of that information in one place to be shared with, collaborated between the DevOps and the security teams for the compliance audit. Right. All right, so what we are seeing here is a Spinnaker pipeline that's fully controlled. The changes to the pipeline are also regulated by the policies. If the policy specifies that you must have the dynamic testing that needs to be part of the pipeline, and that will be enforced. If someone tries to change the pipeline to remove that policy, then the policy will fail to save that pipeline, and the pipeline will still have the dynamic policy in it. So some of these examples in the Spinnaker itself, if you look, just walk through policies that we currently use in some of our customer environments. It's a Sarbanes-Oxley separation of duty policies. So what that requires is there needs to be someone who's triggering the pipeline that's different from the one who approves the pipeline. So you can actually check what the, have the check in there. And if I trigger the pipeline through Git repository and then come and approve here, it would simply reject it saying it's the same person. So these policies are based on the context of the pipeline execution. And it's very easily modifiable in your environment. If you have a slightly different requirement for the Sarbanes-Oxley, that you need to connect to a third-party database to get that kind of an approval that can be fairly easily implemented. So here the validation deployment security at the time of the deployment, we want to have certain rules that are verified. For example, there may be a CIS rules or IAC checks, the infrastructure as code, the deployment checks that you want to specify if there are no new ports that are being opened or a specific port should never be open. You can have those checks specified here. We actually use the Spinnaker capabilities of connecting to infrastructure, pulling the load balancer settings, and verifying those rules. So these are some of the systems that are built in to the system. So if you want to look at the policy, how that looks, you can see that here, because these policies are applied from a central location, everyone gets ability to view the policy, but not edit the policy. Okay. So those are quickly some of the policies and how we apply those policies as part of the process itself. Going back to our presentation. I'm just trying to find the window, sorry.
And if you have questions, please enter them in the chat and we'll answer the questions as soon as Gopi's finished.
Yeah. So, there we go. Do you see my screen now? Yeah.
Not yet.
Oh, okay. All right.
There we go.
All right. So we just went through the delivery process and different checks at the build, source control, and staging, and also in the deployment, and some of the pre-packaged policies that are built into the system that can be applied to the Spinnaker, and the integrations of the Spinnaker with different security tools like Aqua or the Sneak or AppScan or other kinds of tools. So it makes it fairly easy to set up the process and use those templates to provide that to the developers to start using the templated versions of the delivery pipeline. So with the feedback that we have, we are also simplifying how this process gets rolled out to the development groups. And one of the things that we did was we introduced a concept called deployment firewall, which is coming up next week. And Mark, do you want to give some overview on what that is going to be?
Sure. It's great. Hey, thank you, Gopi. And again, please, questions, enter them in. And this is the time we can do Q&A. And so, yeah, next week we have another webinar. It's great, focusing on this concept of deployment firewall. I think what the key thing, Gopi, is what's interesting is, you know, the shift left sort of DevSecOps concept. You know, they've done some of that, but post-build sort of seems to be left out, right? And so I think that's the thing that I know a lot of our customers are struggling with, and why Spinnaker provides such a great, you know, backplane to support. It's a very secure app, but it's like once the build is done, there's still a lot of attack surfaces, like you said, and attack vectors, you know, through the process all the way to production. And so I want to sort of get your thoughts on that. You know, one of the things, and so we've been focusing that at OpsMX, and that's why we're going to focus on this next week with this deployment firewall. And The other concept we want to sort of talk about a little bit, maybe with the attendees, is SBOM has been a pretty big topic in the community, but it's basically created and frozen at build time, and yet there's a lot of metadata and assets that need to be tracked afterwards. Maybe you could provide a little commentary on sort of that whole area.
That's exactly right. So clearly, for faster development, there are some pieces that needed to be shifted left. For example, static code analysis can be built into the IDE for the developers to quickly get a feedback on the changes that they need to make for those resolving the vulnerabilities that they may be introducing there. But what we are also found was in the delivery process, after the build, there are enterprise processes that need to be followed. There are the security groups requirements for specific compliance types that needs to be followed. If you look at NIST 800, different sections like 53 and 218, some deal with the build process, but there are others in the delivery process. So those processes are still evolving, and we find a big gap in how these point tools specifically work. And so for example, binary analysis tools like the Sneak, for example, or Aqua Trivi or Aqua itself, it can generate vulnerabilities for the composition of the Docker images. But after that, verifying the vulnerabilities that may come up later on after the first build, or the Sarbanes-Oxley kind of process requirements of approvals, those are all some of the things that needs to be coded in as well. The other one that we just also looked at, deploying an incorrect image to production. So you may have the images that are built that the dev cycle is faster than what would happen at the production. A dev may build 20 different builds and test them before one of those builds goes into production. And they kind of go into certain repositories, and then there is this step from repository, either going from integration environment repository, excuse me, to production, or from the production to deployment to production. So those are still gaps that are causes for the increased in surface area of the attacks, as well as simple mistakes within an organization. So this concept of the deployment firewall is introduced to ensure those kind of mistakes are not done, and also implement easily. One of the real requirement is it should be straightforward to use and collaborate between the security teams and the DevOps teams. So that's really what we are trying to solve here.
Yeah, it's interesting too. It's Warner Vulgar, the CTO of Amazon, once said, if you build it, you run it, right? But what he probably means is you run it securely,
Yeah.
And so it's sort of like, I'd be curious, the attendees, are there any attendees that are not like DevOps engineers or focused on that are more security oriented? But it just seems that there's a lot of, with this whole shift left movement, that there seems to be more and more responsibilities, more and more, more and more domains that become the responsibility of the people that deploy software, that build and deploy software. So now security, do you take a security guy, and does he secure the pipeline? And does he have enough knowledge of the CD environment? Or do you take a guy that actually is a person that's actually doing, the deployments and the releases, and make them secure it? And I think, our perspective is probably, the people that are working day in, day out with these tools like Spinnaker, they need to have that context of security sort of built in. What are your thoughts there?
You're right. So this concept of you build it, you run it is also this business need, enforcing the speed of delivering the features to the production. So that when you leave the requirement with the development group, they would prioritize features over security. So then we start getting into the same issues on how do we ensure the security and of the systems that are being delivered. And it's difficult to expect every developer to be at the same level in terms of cognizant of the security of the systems. As we saw in some of the examples, the breaches can be fairly damaging. So there are examples of enterprises completely closing down because of these breaches. We've seen a number of these breaches in the last year itself, where either the enterprise has to close down or pay ransom to somebody or lose their complete reputation and a large part of their business. So that level of requirements on the security is difficult for every individual developer to appreciate when they are under pressure to deliver new features. So that's where you need these new tools and processes that provide this guidance and provide the guardrails for the developers to do the right thing in terms of security at the same time that they're trying to deliver features faster. So that is where the Spinnaker pipeline structures, enforcing policies on the requirements of this Spinnaker pipeline, along with shift left and verifying at the deployment time if all the security checks have been passed is very critical.
Yeah, it needs to be embedded, right? It
needs
not,
to be embedded.
It needs, and the original DevOps, wasn't necessarily optimized. The focus wasn't, like you mentioned, with security. It was about speed and then quality. They went go fast. First was move fast and don't break things. That was like the first version. We could call that version 1. Version 2 is move fast, but speed and quality are not mutually exclusive. That's version 2 of DevOps, right? And I think this is version 3. Gopi, what do you think?
Yeah, so definitely security has taken the front seat. Part of it is also government regulations as well. This Executive Order 14028 brought additional focus on the development and delivery practices with the requirements on SBOM. So, and the increase in the number of attacks in the last 1 year itself on the supply chain because of the increased surface area for it is making this front and center. You're right, this is like a version 3, ensure quality, speed, and security of the software that is being delivered.
Great. Well, thank you. On that note, I think we're coming up on we said it was going to be 45 minutes. We're looking good. We'll give the audience any final questions. We'll send everybody the slides and the recording. I want to thank everybody for their time today. And Gopi, thank you so much for your time as well. Everybody have a good day. Thank you.
Thanks, everyone. Thanks.